What this recording is, I'm recording every session in YouTube format. So let's say you're gone for some reason. Maybe you called into work. If you're in athletics, if you're sick, you're gone for whatever reason, then I'll have this YouTube video created of the class, and so that you can watch it later on. If you just need to hear something again, you can go and watch the YouTube video and rewind and so forth. So I'll be recording every class, and that's bad. That's the first one I forgot out of the 8. I've done 8 of these recordings, so I'll get better. I'll remember. Um, okay, so this is the course digital introduction to digital design for since I just started recording. Course content is where I'll put the material, the YouTube links. So after I get done recording this, I'll upload it to YouTube and I'll put the link out there. Also, that'll be where the different drop boxes will be for the material and so forth. Course tools, Blackboard messages. This is where you can send me a message, and I think I've sent my cell phone to everybody at Mulvane and everybody at Arc City. So if you have any trouble connecting or anything, I'll have my phone here with me every time, and I'll be kind of looking for a text or phone call at the beginning class. Middle class, I'll probably assume it's my wife and ignore it. But if you're having trouble connecting or something, you can call me, and I should know a lot more about IDL after tonight. Trial by fire. I've had bad experiences with not being able to use the remote correctly. So we'll see. And then start here is where the syllabus is. And a little bit slow. Click the syllabus here. This is where all your syllabi are for classes. Phone number's there. That's my cell phone. You're welcome to call me anytime. If any time of day or night, doesn't matter. 2 a.m. I sleep the sleep of the dead, so you're not gonna wake me if I'm asleep. So if you don't get hold of me, don't leave a voicemail. Send me a text message, and I may call you back. Like Seth left me a text message, and I could have sat there and pushed the buttons, but then I've been 5 minutes to create it, so that's why I just called you back. But yeah, send me a text saying, hey, I have this question, I'll answer it, or you can say, call me. Just make sure you put your name down so I know who it is exactly. Let's see, office hours. I'm here on Fridays. This is at Wellington Center, and we should have the software installed and everything for the class. There is some student software you can buy if you don't want to come down to Wellington. I'm not going to have you purchase it yet because I want to see what they exactly approved this last Monday to see if it covers student licenses. But if you want to do the design work at home, designing circuits, then that's what the software is for. Let's see. Purpose, a goalless class. The course is designed to provide an introduction to digital design. These concepts provide a foundation for future studies and courses related to engineering and computer engineering. Now, I know you've said it 2 times already, but I'm gonna go around and have everybody say your name and say what your major is, just so I know where everybody's coming from. So I'll go ahead and start here in Wellington. You don't have to. No.
My name is Philip Moraes, and my major is in computer science.
And in Arc City. Are you? Oh, computer engineering. Okay.
I'm just pre-engineering. I don't know what kind of engineering yet.
Oh, okay, pre-engineering. How about Mulvane?
My name is Joseph Isaac. I'm majoring in electrical engineering.
Could you repeat that? The last person, could you repeat the major?
Computer science.
Oh, computer science. Okay. Yeah, the used to be computer science was different at Wichita State. It was a separate program, and then they got into some trouble. They were going to lose their accreditation. Um, and don't get worried. But they were having trouble finding faculty. Um, and government restrictions are such that they would only allow so many professors from other countries. You can't have 100% professors from India. India is an interesting country. It's probably one of the most educated places you probably find. It's like a ton of people go over there got PhDs. But when your government only allows your 4-year college to have so many people from other countries, then that puts a limitation. And they couldn't find anybody. Because to be honest, if you're going into computer science, you're going into engineering, you're probably not going to want to do that for teaching. When I went into education, I took a $21,000 pay cut. And that first year was rough. I couldn't afford a cheeseburger from McDonald's. It was bad. And since then, I do a lot of, I teach overload. I do a lot of extra stuff on the side. I'll do some remote projects, some virtual projects where I create courses and so forth, just because I want to be able to afford a cheeseburger from McDonald's. I love education. I love teaching, so it's worth it to me. But if you got people going out there, they're majoring in engineering, they're majoring in computer science, and they're going to make $90,000 to $100,000, you're probably not going to get them to go to Wichita State and earn $65,000 for salary. It's not going to happen. So what they did then is they merged with the electrical engineering program, because a lot of the people that teach electrical engineering could also then teach the computer science. So they had a good merger there, and they satisfied all the requirements, and I think they have an excellent program. So don't get me wrong about Wichita State. Don't be like worried that it's like, well, I'm not going to Wichita State. They're going to lose their accreditation. Now I think they're top of the line if you're wanting to do engineering, if you're wanting to program in the kind of the lower level, maybe the computer engineering side. They also prepare you for the higher level classes too, but they also give you the very low level. If you're trying to program a spectrum analyzer, for example, very low level programming, then Wichita State prepares you for that. This is probably of all the computer science courses, if you include the people at the different campuses, if you include the online, it's got more. Well, no, the introduction to computer science has more. But this is the second one in terms of enrollment, because again, if you in any of those areas, any kind of certain engineering and then computer science, and you go into Wichita State, you have to have this class. There's no question on that. Now, if you're wondering what other classes there are, there's a statistics class that they offer, but unfortunately, they just offer it, I believe, at Mulvane. Humphrey Womoka teaches that. And that's another one that Wichita State said people should have before they come there. Engineering economics, I think it's just offered at Mulvane again. That's another one that they told us that people going into engineering and so forth should have. Computer science. Or assembly language is the other one. So there's four courses they told us that people going these should have these down before they come to WSU. And I'll offer the assembly language again in kind of the same format in the spring, where doesn't matter what site you're at, I'm going to make sure you can take it if you want. That's my goal. I don't want anybody to be left out. We may have to hear each other twangy every now and then. Like Seth, when you were talking, it was like twang, 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 and so forth. Once they get the network engineering part figured, the networking part figured out, we probably won't have that. There'll still be a little bit of a lag, I think there is via the IDL no matter what. Okay. Upon completion of the course, student will be able to demonstrate various methods representing numbers in different systems, demonstrate various digital logical gates using digital circuit design, find a minimal gate level implementation of Boolean functions for digital circuit, design and analyze circuits using combinatorial. I think that should be combinatorial. I think I typed that wrong. Logic. Design and analyze sequential circuits using combinatorial circuits and various memory elements, and designs shift registers and counters. This was told directly from Wichita State's syllabus. And that's what they said, because we were wanting to get their approval. They said, design this, and this is what you should do. And so we used their textbook. We stole the information directly from their syllabus, from their course competencies. And when they looked at it, they said, well, there's not much we can say. You yeah, the same thing as us. And that was our goal. And that's what we want to keep evolving, because we want people, when they go to WSU, we want them to be 100% prepared. So if you're going to another college, will this class help you? Yes, it'll help you. If you're going to any kind of engineering, no matter where, the same basic principles apply. But we designed it around Wichita State's program, not because I think Wichita State's the best place in the world, but because when I looked at the statistics, about 85% of our computer science students end up going to Wichita State. It's close. It's convenient, isn't it? I think engineering-wise, what other colleges have good? Isn't K-State a good engineering too? Or am I wrong?
Yeah, I think so.
Are they?
Yeah, I think so.
Yeah. Wichita State's probably the best one in the state, I'd say. Expectations this class. The student will attend the class. If you miss it for whatever reason, then again, I'm recording those. If you can't get in to the classroom to attend the class, if you got a laptop, just sign on to your laptop at home. You can still attend the class. You'll have the same functionality as you are sitting in the classroom. So you don't lose anything by being at home. Probably coming in the classroom keeps you motivated, keeps you on target. That would be the only thing. I'm at home. Sometimes I've missed online office hours because I've been screwing off. I'm sitting there watching the movie, and then I'm looking over at time. Oh man, I was supposed to be online half an hour ago, and fly out of my seat. I never have done that for class. I've never sat there playing Call of Duty and realized, ooh, I'm supposed to be teaching class. So it does kind of keep you more on target in some cases. Let's see. Late work. I say be accepted if you communicate with me. Like if you're struggling with something, whether it's course related or non-course related, and you just communicate with me. Say, hey, I had somebody just pass away in my family, and I'm struggling with. I'll work with you on that. If I don't hear from you and you just don't show up for 4 weeks, then then I'll go back to my no late work will be accepted after 2 weeks past original due date. Textbook required materials. Here's a particular textbook. Here's the software we'll be using. So like I say, don't purchase this yet because it might, what they approved on Monday might be covered. Definitely covered here on laptops because he said software. So the laptop's here at Wellington. I purchased this myself 2 days ago, 3 days ago. I haven't installed it yet. I've used software similar to this. I hadn't used this directly. But I was getting worried that they weren't going to approve the software. I thought, well, at least I'm going to be able to buy it myself. I wish I hadn't bought it now. but this allows you and it says to analyze circuit behavior. So it's a 4195. I'll know more about it after I install it this weekend. I'm assuming that whatever they approved on Monday, probably I can't take home anyway. So, but you never know. Some of them they have like a site license where you can put it on multiple machines. Like I think the GIS class that we're teaching has 50 licenses, so it opens up a little bit. But you're designing a circuit. You can see here the different features of that. Okay. And I think the textbook is halfway decent if you rent it. I think I read on Callie's website, I think it's like $90. That's not great. But I think if you buy it, I think it was about $250. So it's like I saw the rental price, like, well, that's good. So, have you bought the book yet or rented it?
Yeah, I got the book.
Did you?
Yeah.
Did you rent it or buy it or?
I rented it. It was like $78.
Oh, okay. Not as bad as I thought.
Yeah.
Okay. And I put here it'll eventually be in the lab at the Sumner Center. Now that they approved it. Okay, so then there's chapter problems that I'll assign. Those are out of the book. Those are handwritten, so you write those on paper, and I'll have an app I can show you that you can scan your paper and then just submit it electronically. So there's no need to mail it in old school or anything. My memory is a little bit better. I can remember what the app was because I've used it quite often in math. Works pretty good. It you take pictures basically, and it saves it to PDF form. Just make sure when you're doing your work that you use either real dark color of some sort. Ink if possible. I don't care if it's messy. Because I've had people do light penciling, and when they take pictures of it and they send it as PDF, some of them I can't even read. So, labs. So this will include the Elvis circuit board labs that we're talking about. It also may include some of the software. Tests. The tests here that I say this will be open note, open book. You'll take them via Blackboard, so be done at home, or if you don't have a computer at home, you can take it in the lab here, type of deal. Pretty much, anything you're working with in computer science, you use a lot of resources. Earlier, somebody in class here, they didn't know how to prevent lit pop-ups come onto their computer. And I couldn't help her. I said, let me go back to my computer here. And I Googled it. By the time I Googled it, she had found it. I didn't know where it was at Microsoft Edge. I think I've used Microsoft Edge one time. And I knew where it was in Google Chrome, but I didn't know where it was on that. So again, we use resources. Let's see. Some or all the work needs to be done at home. Students responsibly plan their time. No quizzes. There'll be chapter tests. Much of the course is project-based. All projects turned in via Blackboard must follow the given guidelines and rubric. No final exam, but there is a final project. Let's see, tutoring and no tutoring available. If you need extra help, I'm here pretty much all day Friday. You can text me or call me on my cell phone. Say, hey, get online, and I'll get on Zoom, and I can work problems on a little tablet here, and you can see what I'm working. I can help you through whatever problems you're having. If you're on a laptop yourself or a desktop, you can share your screen. I can see what you're doing, so I can tell you what you're doing wrong. Withdrawal date 11/15. Talks about what you need to worry about there. I'm not sitting there and read this word for word for you. Emergency. Um, in in Mulvane, you probably have seen your doors. There's a door to the west, where you're at, an exit, and then there's the doors at the in the center. So if you have a fire, go in the other direction. Tornado at Mulvane, you got a basement there, so you can go down the basement. At the Brown Center, um, Brown Center has a basement, so you can go there for a tornado, and then I'm trying to think what BC 201 is. BC 201 is fairly close to a door to exit out of, and if you can't get out that door, then I think there's doors downstairs, so you go down to the basement and go out one of those doors, or there's other doors around there too. Let's see, disability services. And also emergency, just in general. Um, if the if there's 2 inches of ice on the road, I'm probably not going to drive from Mulvane to Wellington. So if there's no class, I will email you through Blackboard and say don't come to class. So if you wake up and you see 2 inches of ice out there, go check your Blackboard before you make the drive in. I had a vice president one time. She lived in Rose Hill, and she drove down here. And that morning, there must have been 2 inches of ice on the road, maybe an inch. And I drove from Mulvane to Udall, going about 2 miles an hour. And it took me probably 50 minutes to get to Udall. And going down the rest of the way to Arc City, I figured it was going to take me another 2 hours. I thought, this is ridiculous. I'm not going to die for Cali. So I turned back around and went home. So and that holds true here also. I'm not, if there's a, now it takes a lot to scare me not to get on the roads. But that ice going back and forth all the way to Udall, it's like, oh, I'm done. Disability Services Program, if you're working with James Brown, and he'll contact me at some point and let me know accommodations, or you will, one of the two. Most of the time, that's extra time on tests. If you need extra time on tests, you definitely can work through the coordinator, but just tell me. Say, if the hour I give you for a test isn't enough, tell me, hey, I need 2 hours, I need 3 hours. Probably won't give you 6 hours, because what you'll find is these software programs will time out. And then you lose your results, and it's just a mess. Okay, grade change appeal, that's more end of semester if you feel like you're done wrong. Student code of conduct, don't smoke, don't use e-cigarettes, don't vape, don't use chewing tobacco, don't say the F word in class, all your standard stuff. Academic code of conduct, don't cheat. Credit hour definition, real boring. You can read that. That just says be respectful of everybody in the class. Then down here, we got the different topics. We'll get a little bit into chapter 1 today. I was very happy to be able to say that. Earlier, when they told me there was no cameras out at Mulvane and in Arc City, I was wondering, I don't know if we'll get very far into this. But this kind of gives you a breakdown. Now, there's, I think, 11 or 12 chapters in the book, but all that Wichita State wants us to cover is the first 6 chapters. So that's what I've planned out here. If we find that we're going through the material a little bit faster and we can cover more, we'll cover more. But these are the ones that they want to see covered. Is there any questions on the syllabus? Okay. Well, I'm going to go grab my book and we'll start looking at some material. So I'll be right back. And I'll kind of jump around a little bit. Specifically, I'm starting at page number 4, where we're dealing with binary numbers. And get there eventually. Go into Paint. Maybe. This might work. Earlier I was talking about how much I love Paint, and now it doesn't feel like it'll do what I want it to do. There, it'll do it. Now we got numbers. And there it goes. Can everybody see that okay? I'm going to ignore that one. Because I think everybody's connected. Okay. So I got 123. And this is our base 10. And we got our digits 0, 1, 2, all the way up to 9. So we got 10 total digits, so it's called base 10. You got a base called binary, and it's base 2. Which means we have 2 digits. So you got 0 and 1. And what you'll find is that some electronic devices are set up to, that's how they communicate. They communicate with zeros and ones, like a kind of an open-closed type of situation. You might say, well, why is that? Well, it works real well with circuit design, with how they're based. In some cases, you may find different bases, and we'll look at other ones, are necessary for just the general requirements for whatever you're looking at. For example, let's see if I can get, I'm not sure if it'll work on this laptop. I haven't actually tried it. It worked too good. Let's see if I can remember it. ipconfig/p. Is that a pause? Obviously not. Let me try to resize that. There it is. You see the local IPv6 address. It says FE80:9181:BF7:8EE3:822F%7 and so forth. That's in hex, and we'll talk about that. That's base 16. So some things in terms of networking, they represent in different systems. Some of the devices you'll run across work base 8, octal, and we'll take a look at that also. So you need to know how to work going back and forth between those. there's a movie, Matrix. I'm sure everybody's seen the Matrix. But the guy's sitting there and he's watching the monitor. I can't even remember what his name is, and it wasn't Tank.
I never watched Matrix.
Never watched it.
No.
It's actually a really good movie from a computer science, engineering standpoint. Thinking about it, from most people just like it because of the violence, which is unfortunate. But if you play 3D video games at all, Matrix 4x4 represents your position of your character in that 3D world. Well, that's where the name the Matrix comes from. Matrix. Each person in the Matrix is represented by four, in theory, four by four matrix. Obviously, if you probably have a huge world like that, then it may be more than if you're trying to simulate that. But with a four by four matrix in a video game, if you could hack in and you could change numbers in that matrix, you could, at the start of Call of Duty, for example, you go from the start and immediately be over on the other side, right next to the people that just spawned, and kill all six of them, or however many players there are. Fantastic, if you could figure out how to do that. And that's what's a little bit quirky about the movie, is because they spawn these agents, which are like computer programs, and so forth. But if the computer program really was controlling it, they could just change numbers of where the matrix is, and the agent could be right next to the person they're chasing after. So, but it's an interesting movie from that standpoint. But anyway, there's Hex. I can ruin any popular movie you like. Okay, you got 123. This is base 10. Different books take different patterns here. So we got 123. And I think they just put parentheses around it every time they do it. No, I'm lying. They don't put parentheses at all. They just put the 10. Well, sometimes they put parentheses, sometimes not. So to tell everybody that's in base 10, they'll put a 10 like that. Smaller, it's kind of set down. This could not be base 2, couldn't be binary, because the only digits you can use for binary are 0 and 1. But if you had a different problem, and let's say you had 110. Well, unless you specified that, is that base 10, base 2, base 8? What base is it? So that's where you could put the base 10 like that. And in computer science, you can see a mixture. Sometimes you may see a binary, sometimes you may see hex, sometimes you may see base 10. So you really need to know what in the world you're working with. Okay, so let me figure out how I can put a flash drive in when all my USB drives are gone. What can I unplug? A mouse? And I got something that'll help us here. Assuming I can see. Of course, it helps if I realize I unplugged my mouse. There it is. And Okay, so this is going to show us how to do conversions. First thing we'll take a look at is we're going to look from binary to decimal. And I'll be right back. I'm going to get my calculator. I don't need it for binary, but I will need it for hex. Because hex is kind of large. I can't do this. This kind of adds up. Okay, so we got 110 that we're going to look at. I probably should a little bit. Let's look at a little bit more exciting example of that. That's not a really good one. Okay, so we got 111011. We'll go with that. And we're trying to figure out what that's in binary. So I'll put a 2 there to indicate binary. And we're trying to see what that's related to. 1, 2, 3, 6 total. So I got 1 there, 2, 3, 4, 5, and 6. Now this far right position, this is going to be 2 to the 0 power. Where does the 2 come from? The 2 is our base, because we said it was base 2. How about if it was base 8, octal? What do you think I'd put here? Yeah, 8 to the 0. And so then this would be 2 to the first, 2 squared, 2 to the third, 2 to the fourth, and 2 to the fifth. Now, if I ever start going too fast on this, you holler at me and say, hey, slow down, and I will. At the other sites, I can see some of you pretty good, but some of you are just kind of a shadow. So I may not be able to tell if you're still writing or not. Now step 1, write down the following chart. You say I got 2 to the 0, 2 to the first, 2 squared, 2 third. It just keeps going up. So you'd add however many blanks you needed. And this is just a basic number. We're going to talk about how to handle signs. We'll talk about how to handle addition, subtraction. So we're going to spend a lot more time on this. The next class, we're going to spend probably about the total 2 hours going into detail on this. Today, we're just going to learn how to convert back and forth. Okay. Now, 2 to the 0. Anything in the 0 power is what? I almost universally hear that in every class. College algebra, 1. Calculus, I'll hear 0, so it's just across the board. Okay, so then I got 2 to the first, 4, 8, 16, 32. And that goes along with this, right? And I'll upload these documents so you can have these to refer to. But that just goes along with the numbers I have here across the bottom. And then I say, if necessary, increase the powers to handle the number if it goes to the far left here. Write the binary number in the blanks. I already did that, so I got those written. And then you multiply the number in the numbers in the blank by the corresponding number in the bottom row and add these up. So I'm going to take this this 1 here. So this 1 right here. And I'll take it times the number in the bottom row here, which is 32. Plus, And then I'll take this next number in this blank, and I'll multiply it times 16. Plus, I'll take this next number, which is 1, times 8. The next number is a 0, so we got 0 times 4. Next number is a 1, so we got 1 times 2. And next number is a 1, so we got 1 times 1. So 1 times 32 is 32. 1 times 16 is 16. 1 times 8 is 8. And 0 times anything is 0, so that drops away. 1 times 2 is 2. 1 times 1 is 1. If I make a basic math error, holler at me. I understand the principles of how to do this, but sometimes I can't add. 32 plus, let me see, 8 plus 2 is 10. 42, 52, 58, 59. Did anybody else get 59? I think that's right. 48, 56, 58, 59. So this number right here in base 2 is equal to 59 in base 10. And that would be our answer. Is there any questions on that way? Does everybody have that written down? Does anybody not have it written down? Let me ask that. Okay, I'll clear that off then. My next class, I should have paint.net installed on here where I can that's interesting. Save changes. Okay, so that was going from binary over to decimal. The other way is not as easy. And if you've done this before, you know there's a shortcut. I'm not going to show us the shortcut for a specific reason. So we'll work with 300 base 10. And we want to convert that to binary. So we're going to go from decimal to binary. Now this is only designed to be decimal numbers less than or equal to 512. Wait till that's okay. It tells me my internet connection's unstable, so that's why I was waiting. I figured if I didn't, all you'd hear is my garbled voice. 2 to the 9th power is 512. So we got 128, 256, 512. Next one's 1024, 2048, 5096. I should know these. If you're in computer science, this is how memory used to be measured. We used to have 6K of memory, then 32K, then 64K. There was a Commodore 64, if you've ever heard of that. It was unique because it had 64K of memory. Think of the RAM you're getting now on your somebody in one of the classes had 32 gig of RAM. I don't remember that wasn't you, was it? No.
My computer has like
16. Yeah, that's the most I have. I want more. But yeah, that's what it's measured in. So went from that, and then it started increasing to, it'll probably increase to terabytes pretty soon. So yeah, that's why these are powers of 2. That's how the memory used to be measured. Probably still is to a certain extent. So write down the following chart. Now we're going up to 300, so I don't need to put 512 down. So let's see, how many do I need then? I need 9 blanks. Why did I do such a hard one? Oh well. 3, 4, 5, 6, 7, 8, 9. And I could write down the powers of 2 if I want, but really all I need is these bottom numbers. So I got 512. 256. 128, 64, 32, 16, 8, 4, 2, and obviously can't count. 1. Oh, I didn't need 512. Never mind. Going senile. Okay, so that's what we got from that over there. It is important to understand where these numbers come from, because then if you're doing this and you don't have this handy little sheet, you know it's just powers of 2. 2 to the 3rd, 2 to the 4th, 2 to the 9th, 2 to the 10th, so on. Okay, so find the initial key number. The key number will be the number being converted. So our initial key number, I'll say Kn, is the number that's being converted, 300. Now, find initial key number. Okay, so old style, divide the key number by the number on the bottom row of step 1 that is less than or equal to the key number. So you're looking for the first one. 512 is not less than or equal to 300, is it? But 256 is. So we're going to start with 256. And I'm going to do old style division. And this is why I have my handy calculator, though I bet I can do these. 256 goes into that 1 time. And then 1 times 256 is 256. Is that 44? Okay. Now, this is our remainder. The 1 that you put up here, that goes in the blank over here above 256. Now our steps here then say, place the answer in the blank above the number you divided by, and the remainder becomes a new key number. So this remainder that I just mentioned is our new key number. So it's now 44. And then it says if the key number is not 0, then go back to step number 3. So we go back to step number 3, and we're looking for the next number that's less than or equal to 44, which would be what? 32. So 32 is the next number that's less than or equal to 44. So if I come over here, I'm going to do old style division. I'm going to take 44 divided by 32. It gives me goes in there 1 time, and then I subtract that. 12. Yeah, 12. Now this 12 is our remainder, but it's also going to be a new key number. And that 1 that we found will go above the 32, like that. Now we're looking for the next number that's less than or equal to 12, which would be what? 8. So then 12 divided by 8, that goes into it 1 time. If I subtract that, that gives me 4. So my new key number is 4. And this 1 that's up here, I'll put above the 8, because that's what I'm dividing by. I'll continue over here. And just as it quits telling me internet connection's unstable. Our new key number is 4. So I'm looking at the next number that's less than or equal to 4, which is 4. 4 goes into 4 one time. 1 times 4 is 4. And if I subtract that, I get 0. Now, this would be our new key number. We'll talk more about that here in a second. So this 1 I'm going to put above the 4, because that's what we divided by. Over here it says if the key number is not 0, then go back to step number 3. Our key number is 0. So this says put zeros in the empty blanks, no leading zeros though. So I put zeros here in these blanks. And 300 base 10 is going to equal to 100101100 base 2. Is there any questions on that example? Do you want to see another one, or you feel good about that one?
Yeah.
I asked you 2 questions, and that was the wrong thing to do.
Don't put a 0.
Yeah, you don't put a 0 at the very
Don't put a
beginning.
0 on the 112.
No, you don't. You can. I wouldn't count it wrong, but some people might get picky about that. You want to see another example? Okay. So let's take a look at another one. Looking, I don't see anybody still writing, so I'm assuming everybody's got that down. And I don't know why I keep grabbing for the mouse that's unplugged, but let's see. File, new. Okay, and let's take a look at, 76. So we got 76 based on 10. This time I'll actually tell you to do what we'll actually do what I told you to do. You don't need to write down 128, 256, 512, because those numbers are all greater than 76, so they don't count. So we'll start at 64. So we've got 64, 32, 16, 8, 4, 2, and down to 1. And again, this goes to 2 to 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth. Okay, now following our instructions, write down the following chart, which I just did. Find the initial key number. The key number will be the number being converted. So our initial key number will be 76. We then look for old style divide the key number by the number on the bottom row of step 1 that is less than or equal to the key number. And I say that when I say this, I mean the largest one. The largest one is 64. '64 will go into 76 one time. 1 times 64 is 64. And that gives us 12. So the 12 is our remainder, but it's also our new key number. And this 1 here I'll put above the 64. Now this is our new key number 12. So I'm looking for the next number that's either less than or equal to 12. 32 is greater than 12. Can't use it. 16 is greater than 12, so I can't use it. So actually, these, even though I have the step saying at the very end, those are actually zeros. So the next number that's less than or equal to 12 is 8. So 8 is going to go to 12 one time. 1 times 8 is 8. Subtract that. 12 minus 8 is 4. 4 is going to be our new key number, and this 1 here goes above the 8. Now I'm looking for the next number that's less than or equal to 4, which would be 4. So I'm going to take 4 divided by 4. That goes into it one time. 1 times 4 is 4, and I subtract it, and I get 0. This 1 here would go above the 4. This would be our new key number, and you could continue it, actually. Because if I took 0 divided by 2, it would give me 0. 1 divided by 0 is 0. But whenever you get 0, that means you're done, and you can fill everything in with zeros. So 76 is equal to 1001100. This is another reason why I find, now that we've shown a couple examples, why I find the Matrix such a humorous show in that regard. Because he's sitting there watching these ones and zeros go across the screen, and he knows exactly what's happening in the Matrix. Well, can you think somebody that can look at all these ones and zeros running across like a digital device, like a computer, and be able to know what's going on? No. They're lying to you if they can. I did have one person one time, they claimed they could read barcodes. Not that I can find anything with the barcode on it. Really nothing with the barcode. Huh. The book, yeah. He claimed he could sit there and read this barcode and tell exactly what it says. We never challenged him. We knew he was lying. But they are different. They are different widths, but you'd have to have a really good eye to be able to sit there and read that. And it's like, okay, that's 1, that's 9, and so forth. Any questions on binary? Well, let's talk about octal then. Then we'll talk about hex. Let me clear that off. Octal is base 8. And binary was 0 and 1. Binary was 2. But it didn't go up to 2, did it? Decimal goes from 0 to 9. It doesn't go up to 10. Octal, what do you think it's going to go up to? 7. Yeah. Let's see. 2, 3, 4, 5, 6, 7. These are the only digits you can use. If you're writing something in octal or interpreting something in octal, you can't have any other digits. So if you were looking at a number, 912, and somebody told you to convert it to binary, or not to binary, to decimal, could this be binary? No. Binary only has zeros and ones. Could it be octal? No, because it has a 9.
There's a 9.
Yeah, you can only have 0 through 7. So then you might question, was like, well, isn't it already decimal? Of course, it might be something else. I don't know what base 9 would be. It's probably got a name. But it's still the same principle as we're going to look at. Okay, so that's octal. Let me bring up PowerPoint, Word again. I grab that mouse again. And we're going to go from octal to decimal. So that's the easier conversion. And the steps on that, we write down the following chart. You got 8 to the 0, 8 to the first, 8 squared, 8 to the third, 8 to the fourth, 8 to the fifth. And we got 1, 8, 8 squared 64, 8 to the third is 512, I guess. 8 to the fourth is 4,096, 8 to the fifth is that. Notice our binary didn't go up very far. It went up, I think I said 512 is the largest it could handle. Well, look at this. This is already pretty high, isn't it? So this is a way you can represent very large numbers with very few digits. And that's one of the ideas behind these different binary systems. Binary is based upon the actual design of the circuit and so forth. But a lot of these are based upon how can we represent something in the smaller form. You know, you might say, well, why does it matter? You know, so put everything in decimal. Well, I bought this track phone here. Cost me $100. What if this had the same memory, same processing power as a PC? This simple Android I bought would cost me a minimum of $500, at least. Um, uh, Not that this is. Oh, here's this remote here for the projector. If we put the same amount of memory that we put into a desktop computer into this, same processing power, this remote that probably cost $50 maybe would cost maybe what, 1,000? You know, or more. Yeah. So it depends on what kind of and so forth. It does not need that much, so you have less to work with. From a programming standpoint, I worked with a I'm writing on this tablet with this little pen, but on the production floor they had little pens to scan in barcodes. So when they put the PCB board inside the Spectrum Analyzer, then they could scan which one is going in, so that if they had a recall, like if an electrical engineer designed a PCB board poorly and it was going to fail, then we could contact the customers proactively, and especially with the military, they definitely weren't happy if their Spectrum Analyzer bombed out in the middle of Afghanistan when they were testing something. So we could contact them proactively and say, hey, we need to recall those. We'll give you temporary ones, but we need to recall those because there's a system design error. So they would scan these in. Well, obviously you don't need much memory on these, right? These little scanners that they had would run about $50 per workstation, and we'd need about 100 of them across the production floor. Well, if you take that 100 and multiply it times a small amount, it's not very much. You take 100 and you multiply it times $1,000, and you got $100,000 just so we can scan that. So they don't put much memory in it. So from a programming standpoint, I had to really figure out, and I didn't do much of it. The person I worked with, she did the majority of it, which I bless her. I just had to do a little bit, and I hated it. It was a programming language, IRL, Interactive Reader Language, or Interactive Reading Language, Reader Language. And you had very little memory to work with, so it was very hard to program. And that's some of the things you have to think about if you're going electrical engineering. If you're designing something that doesn't have access to a lot of resources, then you're limited. Okay. Long story short, to say one of the reasons they use different systems. Okay, so we're going to write down this, and I guess I'll go ahead and make up an example first. And we're going from octal to decimal. So let's say I got 712. And this is octal, so I put a base 8 to the side. By the way, you can make up your own base on this. You could put base 9, What digits would a base 9 be? Yeah. 0 to 8, exactly. I don't know if anything uses different bases like that. You'll find binary, octal, and hex are the popular ones, besides the decimal, of course. Okay, so I need, appears like I need 3 blanks. Like this. And we're starting to the far right, which is 8 to the 0, which is 1. And we got 8 to the first, which is 8. And we got 8 squared, which is 64. And that's what our instructions are telling us to do. They're telling us to write down the following chart, and then it says write the octal number in the blanks. So we're going to take that 712, it's base 8, and write in the blanks. And then it says multiply the numbers in the blank by the corresponding number in the bottom row and add these up. This is your answer. What that means is we're going to take this 7 up here. We're going to multiply it times 64. Plus, we're going to take this 1 up here and multiply it times the 8. Plus, we'll take the 2 up here and multiply it times the 1. Let's see. 7 times 4 is 28. 8 carry the 2. 7 times 6 is 42. 44, that's right. 1 times 8 is 8. 2 times 1 is 2. which gives us 458 base 10. Now you might look at that and say, well, yeah, you saved a lot of memory space there, didn't you? You know, you had 3 digits here, you had 3 digits here. It actually shows the benefit a lot better when you deal with larger numbers. So. And in programming, in networking, it actually gives you more possibilities, which we'll talk about with base 16. Is there any questions from going from octal to decimal? I think everybody's done writing.
I have a question.
Sure.
So, is this a type of compression? Like WinRAR or whatever?
It can be. It depends on what you're designing and so forth, but definitely representing whatever data you're working with in a smaller form will allow you to have compressed data. Now, in terms of compression, there's lots of different ways you can compress data, and whether it's because you have little memory or because you want it to be a fast delivery system. I took a class at Wichita State called Wavelets, and the class was about you can on your phone you can watch a video. It's fantastic. I can sit here, I can bring up a YouTube video, and I can watch it. And it's actually got a little bit better performance than our Wellington Center right now. Just by a simple phone, right? $100 device. How do they do that? Well, when you got the original video, if you've ever created any kind of video, I did it for a company one time. They did not like the quality of my work because my lighting wasn't quite right and the audio just wasn't the perfection that they wanted. And they want perfection. It was a class, 2 classes I designed for World Quant University. They offer a free master's degree in quantitative finance. And they wanted the best quality. And I could not get it as good as they wanted. And I finally took all the compression off when I was recording a video. It was a 5-minute video. It was huge how much space it took up on a hard drive. There was no way I could have a 15-minute video with the disk space I had. You have to have some kind of compression. If you go with no compression at all, no transformation, it's just huge. Well, when you got this and you want a video to fly through the air into your phone so you can watch it, what it has to be done is it has to be compressed, has to be transformed, flown through the air. You receive it on this end, and then it reintegrates the video on this side. And so a lot of college algebra actually is used in that. So the requirements for the Wavelets class wasn't huge, but it's just showing how do you design something. You can be an engineer and you can design the best little device here, but if I have to send across 2 terabytes of video before they can watch it and have it look decent, it's crap. So that's one of the areas you see that. Unfortunately, it was an all theory class. I was wanting to actually program that. I wanted to learn how to take a video and how to transform it into a small image, then save it off somewhere, and then retransform it back. But we didn't get into that. Probably because that's like a 2-year program to learn how to do that. But people, probably that's their sole function is how can you deliver a video so it looks good and doesn't take up space. Like if I look at, for example, at both places, both Arc City and Mulvane, do they look good to you here? Do they look good if you look at the pictures?
Yeah, it looks good from distance.
Yeah, they're small, right? Now, if it had to send the uncompressed, untransformed video, this wouldn't even be possible. So what it's doing on its end is it's taking the technology there is taking the video, it's transforming it, and then transmitting that. And that's what it's doing here. This Logitech camera they hooked up. It's taking the video, high definition, because I see the HD on it. It's transforming it into a smaller, and then sending it over the lines. Probably more information you want to know on that. Okay, so that's going from octal to decimal. So let's look at going the other direction. Only lets me undo so much. Okay, so we're going to go from decimal to octal. So let's say, I don't know, 1,123 and base 10. We want to put that in octal. Yeah. Decimal to octal. And it says, write down the following chart. So if I scroll down a little bit, it might help. Okay, so write down the following chart. Now we still do not need to worry about numbers that do not apply. So we're looking for the first number that's less than or equal to 1,123, which would be the 512. So it looks like we need 4 blanks. So this is 8 to the 0 again. This is 8 to the first, 8 squared, 8 to the third. 8 to the 0 is 1, 8 to the first is 8, 8 squared is 64, 8 to the third, I have no clue. 512. Next number was 4,096, bigger. Okay. So step 2, find initial key number. The key number will be the number being converted. Well, we're converting this right here. So our key number is going to be 1,123. And it says in the next step, old style divide the key number by the number on the bottom row of step 1 is less than or equal to the key number. So our first number that's less than or equal to it is 512. Let's see, 512 doesn't go into 112, does go into that probably 2 times. 2 times 2 is 4, 2 times 1 is 2, 2 times 5 is 10. I don't know, I can't do basic math. So we got 1,023 minus 1,024. Oops, try it again. 1123 minus 1024 gives us 99. Now, this is our remainder, but that's also our new key number. And then we're going to put the number 2 above what we're dividing by, which is 512. Now, I'm looking for the next number that's less than or equal to our key number. Next one, 64. So I'm going to do 64 into 99. It goes there one time. I might have to do this without a calculator. 535. This is our remainder, but this is also our new key number, and the 1 goes above the 64. And so then our next number that's less than or equal to 35, our new key number is 8. So 8's going to go in 35, was that 4 times?
Yeah.
4 times 8 is 32. Subtract that. This is our new key number, and the 4 goes above what we're dividing by. And then it's kind of trivial, but if I take the 3 and I divide by 1, using the same step-by-step process, 1 goes into 3 times. 3 times 1 is 3. Subtract that. This is our new key number, our remainder. And the 3 goes above what we're dividing by, which is this. So basically, your last number, what do you do with it? Just put it directly in your last blank. So if you see that, fantastic. If you don't, just follow those steps, and it works out that way anyway. So 1,123 base 10 is equal to 2,143 base 8. Can you hear me okay? Maybe. I heard a. Okay. Yeah, I heard it was like a. So I didn't know if it had if I'd lost you. Oh, that's no problem. I'll show one more example of this. I don't think we'll get to base 16 today. But let me clear this off. I think everybody's got that written down. Is there any questions so far on that? Okay. And what's my largest number here? Let me see. 32,000. So let me choose something smaller than that, but still pretty big. Like 27,112, I guess. So base 10. And we want to convert that to octal. Well, in this one, we're not going to use this first blank, but it looks like we need 5 blanks. 3, 4, 5. This is 8 to the 0, which is 1. We got 8 to the first, which is 8. We got 8 squared, which is 64. We got 8 to the third, which I have no clue. 512. And 8 to the fourth, which is 4,096. Yeah. Okay, so we're going to start with the first number that's, I should say initially our key number is 27,112. So I'm looking for my first number that's less than or equal to that, which would be 4,096. So I'll have paint.net installed before next time. I can't see my cursor. It's a little paint.net. I've used it over and over for the same thing, and so I'm sitting there guessing where in the world my mouse is. Okay, so it doesn't go into 2,711, so it does go in 27,000 probably 6 times?
Yeah.
Is it 6? Okay. Let's see. 40, 96. Turn the calculator on. 40, 96 times 6 gives us 24,576. I'll subtract those. 2,712 minus 24,576. And that gives us a remainder of 2,536. So this is our remainder, but that's also a new key number. And we'll put the 6 above what we're dividing by. So then I'll look for my next number that's less than or equal to that, which would be 512. Probably goes in there 5 times if I had to guess. Maybe not. Wow. No, okay, I'm wrong. 4 times, right?
Yeah.
Yeah.
I was thinking it was perfect. I thought it came out 2536 when I multiplied those together, but go to the casino if I was that lucky. I think that's right. 8, 4, okay. And 2536 minus 2048 gives us 488. The 488 is our new key number. So I'll put the 4 above where we're dividing by, which is 512. Now I'm looking for the next number that's less than or equal to that, which would be 64. Um, 7 maybe? I think 7. 8, 2, 42, 44. Yeah, it wouldn't be 8, would it?
7.
Is it 7? Okay. And so give us 40. Okay, so 40 is our new key number, and the 7 goes above this. And so then I'm going to take my new key number, the 40, and I'm going to divide it by 8, because that's the next number that's less than or equal to that. And that does go in perfectly. It goes in 5 times. 5 times 8 is 40. Subtract that, we get a 0. This is our new key number. The 5 goes above where we're dividing by. And since it's 0, then I fill in the remaining blanks with 0 itself. So 27,112 is equal to 64,750 base 8. And that would be your answer. Is there any questions on that? Okay. I don't see anybody. I mean, I still do. Okay. I'm going to put an assignment out there. And I'm going to plug my mouse back in. Now that I'm done with the tablet. That way I can actually, in theory, see my mouse. And convert the following decimal numbers to both octal and binary, base 8 and base 2. So let me see, 312 and 85. And convert the following octal numbers to decimal. So let's say we got 3, 4, 5, 1, and 8, 7, 8. Octal. What should an octal have? It shouldn't have the 8. Let's try that again. 713. I need to make up questions that actually make sense. And convert the following binary numbers to decimal. So we got 1110011 and 1001101. Now I'm going to upload this, and I'll put the Dropbox out in Blackboard. So you can work this. You can do it on paper if you want, and take a picture of it with your phone, and upload that if you want. It can just be the image JPEG. I'll eventually get that app so you can put it in PDF form. I'll remember the name, or I'll look up the name of it. But that'll be the first homework assignment. I'll also upload those sheets on how to do the conversion with the steps. So if you need to see those. Is there any questions on any of that?
Can we just do them on Word and send them to you?
You definitely can.
Do the homework on Word. All right.
Right. And well, oh, go ahead. I'm sorry. Okay. Well, that's the end of class. Class goes from 1:30 to 3:20. So we'll go ahead and call it quits there. And I'll see you again on Monday, and we're going to go into hex. And we'll also look at how in the world do we handle decimal? How do we handle signs? And then we'll also get into like addition, subtraction, and so forth. So I'll go ahead and stop the recording there.